let's start with the basic logic elements. If you have a circuit like this, and you're controlling a lamp, so that's a normally open switch controlling a lamp, what would happen, we could write what we call the truth table. If this is the push button 1, PB1, you can have the input as either not pressed or pressed. We represent that with the 0 and 1. And then your output would be exactly the same. So in your red lamp, if we switch this push button to the normally closed contacts, we're going to see that this logic will be reversed. So the way you draw a normally closed push button, you assume that there's a spring pushing up, and this would be push button 1. Now your logic is reversed. For this, we call this not logic. It's the opposite of what you put in there. So that's not logic. First one actually has a name. It's called simple logic, where it's just 0, 0, 1 is 1. Now, let's say we want to put 2 push buttons in series. So we'll use a red lamp. These are our rails. This would be, for instance, power. You could say it's 24 volts, and this could be your common. And so what you would do is put 2 push buttons in series, BB1, BB2. What is the truth table for that? You put PB1, PB2. First case, if neither is pressed, no energy can go through the circuit. You need to have a complete circuit, so the red lamp would be not energized. If we energize only the second push button, the energy cannot get through the first push button, it will not get to the lamp, and nothing will happen. So the lamp will not come on. Now if we do only PB1 and not PB2, same issue. If we press PB1 and PB2, energy would get through the first push button, second push button, and we would energize the lamp. This is what we would call AND logic, because you have to have push button 1 and push button 2. So we are using the simple terms in English to describe the basic logic element. So now we have done the not and the and. What we will move on to is putting these 2 push buttons in parallel. So when you draw a push button parallel, your first one, and you want to make a branch for your second one. Technically, you should have connection points in every place like that. I'm being a little bit sloppy here. And we can call this PB1 and PB2. Let's go back and write our truth table. In this case, if you don't press either button, the red lamp has no output. If you press only only PB2 and not PB1, the energy can go through PB2 and create a connection for the red lamp. Alternatively, you can go through only PB1 and turn on the red lamp. And of course, if you press both of those buttons, then you have the red lamp energized. We can press PB1 or PB2. So we call this OR logic. We cover not, and or logic, you press one or the other. See, I think I'll keep my truth table here and just change the logic. Here, we will use normally closed switches and see how that impacts our circuit. You draw these directly under. Remember, it's kind of like a spring is holding this up. If you press neither light, or neither switch, here, we will have an output. If you press one or the other, you still will have an output. But if you press both buttons, you will have no output. Now, if you look at this, this is the opposite of AND. So we call it not AND. Remember, the not originally was just turning the opposite of one, but now we're doing AND. If I'm a right AND here, the logic for AND would be 0, 0, 0, 1. We just did that. So NAND, this is representing NAND, not AND. And finally, what we want to do is represent two normally closed push buttons in series. Output here will be, if you press none of the buttons, you'll have a lamp on, but if you press either one or both, it will break that circuit. And if we look here and remember that OR logic, just writing here just so we can remember, was 0, 1, 1, 1. So this would be not OR, which we call NOR. Those are your basic logic elements: not, NAND, NOR, and OR, whatever order you want to say those in. And we will need to do another video on memory.